All right, let's look at a few problems from 14.4 homework. So I'm actually going to skip through to some of the more interesting ones. If you kind of look through the homework, I did some that were very similar to these. Some of the rest are just definitions. So let's look at number 4. So 4, 5, and 6 are not intended to be too difficult, but I wanted to look at them briefly. So the question is whether ABC is a tree or not. All right, so the question really is, is it connected? Yes. Are there any circuits? No. So this is a graph. This is a tree, I'm sorry. Number 5, okay, it is connected, great, but there's a circuit right there, so it's not a tree because it has a circuit. And then number 6 is a little more interesting, so it might take a little longer to look at. So let's make sure everything is connected, meaning do the vertices connect to another vertices by an edge? Yes, yes. Basically, I'm looking to see if any vertices are just living out in space, or if there's a pod of vertices separated from this pod. All right, they're all connected. Are there any circuits? There are no circuits, so it is a tree. So you'll breeze through some of these pretty quickly. All right, let's see, number 10 and 11. Number 10 is just kind of wordy. It's not really too hard, but it's just a lot to read. So we want to see, well, basically, use a tree model to the parent-child relationship. So to be honest, these better be some trees. Okay, they look like they're mostly trees. So I could throw away anything that's not a tree, anything that makes a circuit, and just throw that out, which is A. But let's just read the question. So Paloma has 3 children. Paloma's P. Shelly, Lulu, and Kevin. So that's what these vertices are. All right, then is what we got to read next. Lulu has no children. So this means that under Lulu, she should not have anything after her. So it could be A, it's not, but it could be A, not B. In fact, I'm going to go ahead and scratch off A because this is a circuit. It's not B because this shows that Lulu has kids. Okay. Also, it can't be C because Lulu has 2 kids here. All right, so I've narrowed it down to D, but let's just confirm it's correct. All right, so Lulu has no children. Kevin has 3. And then, oh yeah, Kevin has 3. Shelly has no children. I skipped over Shelly. Sorry about that. All right, so it's D. Okay. Number 11. This one we didn't exactly discuss precisely in the notes, but let's look at it. Give an example of a tree with 5 vertices. They all have 5 vertices, and the degrees are 1, 1, 2, 2, 2. So what I'm going to do, since it's multiple choice, I'm going to go through and I'm going to write out every degree of each vertices. So A has 2, 1, 2. B has 2. D has 2. E has 2. C has 2. So it can't be A. It's not A. All right, let's look at B. A has 1. B has 2. C has 2. D has 2. And E has 1. All right, so we should have 2 1s, 3 2s. I think it's B. go ahead and circle that one. Let's just confirm that C is not correct. This has 1, B is 1, B is 1, D is 1, C is 4. So that's definitely not it. Okay. Okay. Number 13 and 14, I probably could just do one of them for you, but we'll do both. Number 13, we move on to spanning trees. So here's our graph. Okay. With a spanning tree, we are not allowed to add any extra edges. So that's where I'm going to start. I'm going to look at this. Notice here they have a couple of extra. They have CD. Notice CD is not in that, so throw him away. I'm thinking B is it, but let's look at C. C, they've added DE. Well, DE is not in the original, so throw him away. And then in option D, they've added a F, which was not in the original. Okay, so this is our answer. Everything is connected by a single edge. Each vertices only has, or each pair of vertices is only connected by an edge. It doesn't make a circuit, so it's B. All right, number 14, we've seen this dog bone shape before. The question is find the correct spanning tree. Okay. Well, my first thing I want to look for is any circuits. These are circuits. It's also not connected. Okay, so I'm going to throw that away. I also want to throw away anything that's not connected. So these are not connected. These are not connected. The only one that works is B. It has to be connected, and there can't be a circuit. I think this homework is going to be very quick for you. Okay. So we'll do a couple more and probably wrap it up. Number 16. Find 4 spanning trees for the connected graph. Very good. So I want to make sure, all right, I got 6 options. I want to make sure there are no circuits and it is connected. Okay, so right away, if I see any circuits, I throw them away. No circuit, no circuit, circuit. Throw it away. Also right here, circuit. I'm looking at this. All right. No, that is not a circuit. That's my fault. Also, I'm going to make a point about this as well. So C is actually okay. This is not a circuit because this right here, this intersection here is not a vertices. So C is okay. Sorry, C. Oops. C is okay. Let me show you F. As I looked at it, if you look really close between B and D, it looks like those are not connected. Okay? Even though it looks like B and D may not touch or may not be connected. They are. So The homework is not going to try to trick you. This is either a mistake with the printing, or on my math lab, the edge just doesn't go all the way. Okay, if it looks like it's going all the way, it is. Okay, if it doesn't, then it would look something like this. Okay, they're not going to just stop halfway in space. So this makes a circuit. C, B is okay. Also E, even though that looks like a circuit, there's no vertices there in the middle. So that one's okay. And so A and D. All right. And that's referring to this one. Okay, so there's 4 of them. I knew there were 4. That was the only one that doesn't work. Okay, let's move on. Now we're going to start using Kruskal's algorithm. We'll do 2 examples of this, one that's a little easier and one that's a little more challenging. This is number 20. It says use Kruskal's algorithm to find a minimum spanning tree. So got to do the minimum spanning tree. Here we go. Each of these are spanning trees, but we want to find the minimum. So like I said, we're going to write out all of my weighted edges. And as I do that, I circle them on my graph, so that I don't make that mistake. I circle them so that I know that I kept up with them. Okay, so 4, 8, 14, 15, and 22. Now, the rule is I start with my smallest 2, 14 and 8. Okay, you get the first 2 for free. Then the question arises when we get to the third one. Okay, we move to 14. Will 14 make a circuit with 4 and 8? It will not, so we get 14 as well. Now, if I move to 15, that forms a circuit, so we can't use it. So I'm going to scratch that out. If I move to 22, it also makes a circuit, so that's no good. So you can redraw it if you want. I'm just going to look at it. It's this thing here, so that's the answer there. Then to find the total weight, I add the numbers I've highlighted. Okay. 4 plus 8 plus 14, that's 12 plus 14, which is 26. So let's do one more of these Kruskal algorithm ones. Number 21. It's a little more involved, not too bad. I'll leave the real fun ones for you. All right. Again, use Kruskal's algorithm to do this. All right, so you just got to do it. I probably want some more room, so I'm going to grab a sheet of paper so I can have more space. All right, so let's see if I can find the smallest number. 71, 60 is the smallest. And of course, as I get to them, I'm going to circle them. 65 is the next one. Any more 60s, 67. All right, any more 60s? No. Now we move on to the 70s. 71, 74, 75, and 79, 80. Okay, so I've got them all. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I start with my smallest two, I get those for free. 65 and 60. Now 60 is not this little piece here. 60 is that whole thing. That's a little tricky, I think. All right, now I get to move on to my third one, which is 67. Does it create a circuit? No, so 67. Now, I get to 71. 71 will also not create a circuit. So, 71. All right, 74. Uh-oh, that would create a circuit. So throw away 74. 75. Oh, 75 also creates a circuit right here, so we can't use it. 79. Let's see. Remember, what do we got left? 79 and 81. Yeah, looks like we might get a circuit there. Okay, boom, 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 boom. Yeah, that one's no good. And 81 also is going to give me a circuit. Same thing. Yeah, so not that. So we only got those four. I'm gonna write those down here. Well, actually, now that we have the graph, that's the first step. You can see the highlighter. It looks like this kind of weird S. And then the total weight, I got to do that here. 60 plus 65 plus 67 plus 71. Let's go. 60 plus 65 plus 67 plus 71 is 263. Okay. So that's going to wrap up our homework for 14.4. All the other questions are practically the same. Some are a little, maybe a little more challenging, but it's basic concept.